Part 2. We will learn how to complete or repair solutions of equations, how to construct a table of solutions, how to graph linear equations by plotting points, and how to use graph of linear equation to solve applied problems.
Logical evolution for graphing linear equations by plotting points. We will focus in this presentation on constructing a table of solutions. This method is comprehensive. You can use this method for graphing any equation into variables. So we will talk about details, how to pick value for x and how to find corresponding values for y's. After that, we will work out project, and finally, we will practice how to read and interpret graphs.
Now let's go back to the graph of linear equation into variables y equals x and positive. The graph is straight line. As we talked, the graph is location for points, infinitely many of them, and each point is solution of this equation. Now question is, if graph is straight line, how many points do we really need in order to graph this line? So we are going to talk how to graph linear equation into variables. If we have just one point, just one from all of those billions, millions, infinitely many points, is it enough to graph straight line or not? Maybe not, but if we have 2 points, then life is secure and it's enough to graph a straight line. As you see, now we need any 2 points. We need any 2 solutions for linear equation into variables in order to graph a straight line. How can we find points to graph a straight line? We can use several methods. The simplest is table method. You have to build a table. X is the first column, second column would be for an equation, and third for y. And then you have to pick any value for x, whatever you wish, from available on your rectangular coordinate system. I pick 2, and then you have to calculate how much would be y if x is 2. 2 and 2 is just 4. So now you have first point with coordinates 2, 4. And you can plot this point. After that, you have to pick again any value for x which is available for you. I pick -6. And then I have to calculate how much would be y if x is -6. As you see, -6 and +2 will be just -4. As a result, I have point with coordinates -6, -4. Now I can plot this point, -6, -4. So I have second point. If I have 2 points, I can graph a straight line. Another example, we have request graph a linear equation into variables y equals -1x and +2. And we want to use table method. So left column is for x, middle column is for an equation, and then right column is for y. And what will be a good idea for you if we have -1x? It's a good idea to use parentheses around x, because by itself x coordinates, they can be positive or they can be negative, and without parentheses it's easy to make a mistake. So now let's pick any value for x which is available in our rectangular coordinate system, I will use 2 as before. So now I have to replace x, only and only x, by 2. So you see, I am going to put 2 within parentheses. And now I have to simplify. Negative 1 times positive 2 to be negative 2, and then plus 2 and positive 2, result is 0. So the first point will be with coordinates 2, 0. And then I can plot the first point. Second point, I'm looking for a second point. I have to pick again any value for x which is available. I use negative 6 again. And look what will happen. X is negative 6. How much would be corresponding y? Without parentheses, it's easy to make a mistake. But parentheses can help me, because now I have to remove parentheses. Negative times negative would be positive 6, and positive 2. Result would be positive 8. Y is 8. So now I have second point, negative 6, 8. And I can plot second point, negative 6, 8. Having 2 points, it's not a problem to graph a straight line. Graphs are a very popular way to present information, and ability to read graphs and interpret them is very important. So we are going to focus on how to read and how to interpret graphs of linear equations. In the most of daily life problems, we don't use 4 quadrants of rectangular coordinate system. We just use the first one in most problems. Now let's have fun. During spring you can buy chicks on Saturday market. $1 per chick and $2 for plastic cage to keep them, up to 10 chicks. Equation for the purchase is y equals positive 1x and positive 2, or we can say y equals x and positive 2, where y is the total cost of your purchase, x is number of chicks. On the right, you can see an equation and corresponding graph. If you want to read and understand graph, first you have to pay attention what is on your x-axis. In this case, it's number of chicks. And what is on your y-axis? On y-axis is, in this case, cost of your purchase in dollars. Now, for instance, if you bought 4 chicks, how much did you invest in this very serious business? Look into graph and you can see $6. Or, if you're ready to invest $7 in this very serious chicken business, how many chicks can you buy? Look into graph and you will see only 5. This is how to read and interpret graphs. Good luck! Fun part of this problem. As you remember, from algebraic point of view, straight line, which is graph, represent location for points, and all of those points supposed to be the solution of the corresponding equation, y equal positive 1x and positive 2. This is from algebraic point of view, but we are talking about real life problem. So x represent number of chicks. We can't use fractions for number of chicks. We can't use decimals for number of chicks. We can use only and only whole numbers. So we have to use points. When x is 0, y is 2. When x is 1, y is 3. When x is 2, y is 4. When x is 4, y is 6, and so on. So as you see, we can't use here solid line as a graph. we have to use separate points. And in Math 111, you will learn this type of relations, and you will call them sequences. But as for now, I just want you to see algebraic approach and real-life problem. But if you would change our chicks into strawberries, then it will be a different story, because strawberries in pounds and cost in dollars, and we can use the same equation and graph would be a straight line. As you see now, it's not only formal approach, you have to use logical approach and your life experience. Project reading and interpreting graphs. On the next slide, click play on the bottom of the screen to begin viewing demonstration for this project. Your project is on the Moodle for extra credit. Solve problems, print your project and turn in on Monday. Demonstration for project. Reading and interpreting graphs. Your project is on the Moodle for extra credit. Solve all problems and print your project for extra credit, and you can turn in as a part of your homework next Monday. Now let's go back to demonstration. I will use this navigation and let's read. Cost of service each towing company determines using formula purple company y equal 4x, green company y equal 3x and positive 5, brown company y equal 2x and positive 20, where y is the total cost in dollars, x is the distance in miles. Let's look what we have on x-axis. On x-axis we have distance in miles, but we have to pay attention to scale. From 0 to 10 we have 1, 2, 3, 4, 5 cells. So each cell would be 2 units. On y-axis we have total cost in dollars. And from 0 to 25 we have 1, 2, 3, 4, 5 cells. So each cell is $5. Now let's read the question. Using corresponding graphs, you have to choose the cheapest towing company to tow your car for 2 miles. Okay, for 2 miles, let's mark distance 2 miles and let's look which company would be the cheapest. It's clear it's not brown, it's not green, it's purple. So we have to highlight and we have to type purple. Purple. Next question would be distance is 10 miles. Let's move 10 miles and let's look which one would be the cheapest. The cheapest would be green one. Okay, we have to highlight and show green. Then next would be 20 miles. Okay, let's look into 20 miles. We have to extend to see better. And it's clear that the cheapest would be brown. Now let's move to the next question. Using corresponding graphs, estimate total cheapest cost to tow your car for 2 miles. Okay, let's go back to 2 miles and when you're using graphs, it's not exact. You can estimate something.
It looks like it's 8 miles. All the equation gives you exact answer. Graph gives you approximately. It's $2. Now, for 10 miles, let's look what we have for 10 miles. We have $35. And for 20 miles, the cheapest would be, okay, so what do we have? 50, 55, 60. $60. Okay, now let's read the third question. Using corresponding graphs, estimate mileage which each company can provide for $80. Okay, now let's go back. Okay, for $80, 75, and we have to show 80. Okay, here we are. So now let's look what we have for $80. Purple company can provide 20 miles. Green company 25 miles. 25 miles. And Brown company, sometimes it's not easy, but it's possible to correct, or you can use better scale. So answer is 30 miles. Again, your project is on the next slide, which is on the Moodle. Do your project, print your project, and turn as a part of your homework for extra credit.